Trigonometry. Three, gone, angles, metric, measure. Trigonometry is to deal with measuring angles within a triangle. Okay, and what's really cool is like Pythagoras, where if you have a right triangle, you have special properties, a relationship between the sides. Trigonometry is how we look at the relationship between the angles, such as this angle or that angle. We know that the 90-degree angle is 90 degrees, and we look at how that can show us the relationship between the lengths of, what did we call them, A and B and C before. Well, now we're going to get a little bit more sophisticated, and we're going to use some different words, some big girl words here. So for a right-angled triangle with another angle, theta. So that symbol, you can draw it any way you like. Theta can come around and go like that. It's the Greek letter theta. We don't have to use theta, but and I think we say theta in Australia, but it is a Greek letter that sits in place of an angle. So I'm going to draw mine like that. That's theta. It could be this one. Doesn't matter which one, but we'll call it theta. And it's just convention that we do that. There's no real reason to do that. You could call it X or Y, but that's what that little symbol is. Now, instead of using A's and B's and C's, we're going to use fancy pants terms. The hypotenuse, that's going to always be the longest side, and it's going to be opposite of the 90 degrees. This is not news. But now, once we have an angle theta, so if I'm looking at this angle rather than this one, because the answers will be different, I'm looking at making this my theta. So opposite. So now that I've decided that that's theta, the one that is opposite is going to be over here. That's the opposite side, and this is going to make sense in a minute. And remember, the word adjacent means next to. So this one is adjacent. Well, you could say, well, the hypotenuse is adjacent as well, but that has a special name. Okay, so the one that is adjacent and not the hypotenuse, that's that one. So over here, I can't do anything except name the hypotenuse until I decide what angle theta or x is going to be. Let's call them x. This one, okay? So the one that is next to x or adjacent, the one that is opposite x is this one. Okay, so why do we care? Let's look. So it so happens that this angle, once we know what that angle is, if I change the size of this, if I change the side lengths of a triangle, but I still had a 90 degree, and whatever theta is remains the same. So I can have a triangle with side lengths that are, what did we have, 3, 4, 5, and then I can have one where I double all the side lengths, and the angles will remain the same. And they actually have a really special relationship with each other. And for those, we have fancy pants names. So for a right-angled triangle with the given angle theta, so we need to decide which angle is theta, like in this example, that's what that one is there. We have these ratios. So the ratios are going to tell us that if we look at sine, cosine, and tangent, each of them is just going to give us a ratio. So let me explain. The sine of angle theta. Sine theta is sine of this angle theta. So I would call it sine theta, is equal to the length of the opposite side, so whatever that is going to be, divided by the length of the hypotenuse. And don't ask me why. Somebody far smarter than me in past ancient history realized that this was the case. Not only was a squared plus b squared equal to the hypotenuse squared, but actually these angles can tell me that if whatever that angle is, the sine of that angle, that is going to give me a relationship. It's going to give me a fraction of whatever O is divided by whatever H is. That's a fraction that can turn into a decimal, right? Next to that, I have another option. The cosine, or cos, of angle theta, because it's always going to be of an angle, is equal to the adjacent side. So that's this guy over top of the hypotenuse. So it's kind of similar to the cosine. Kind of crazy. And that's what's going to give us, if I had numbers for A and H, they would make a fraction for me, and then I would be able to tell you what that relationship is. And that's what the cosine is. That's what that ratio is, the word I'd rather use. And then finally, the other one is tangent. And what haven't we used yet? The tangent of theta, or tan theta, is equal to opposite over adjacent. So between cosine, sine, cosine, and tangent, we've used each of the three sides, and we've used them each a little bit differently. So this is a starting point for us. Label the triangle below with the sides. Okay. I've done that. Now, if you want to remember which is which, like how do I remember this? We use the term SOHCAHTOA. And so you will have need of this for the rest of your mathematical lives. SOHCAHTOA is, and I like writing it this way. This is the way Miss Rafferty writes it. Sine, so. So I'm writing the same thing as this. S-O-H, S-O on the top, H on the bottom. Ka, with an A on the top. I'll write a high uppercase A, doesn't matter. And then Toa. Look at that. So that also, in the order, it tells us which is on top and which is on bottom of our fraction. So write the trig ratio and fraction form of the following triangles. So now we have to think. I'll write it again. So, ka, toa. And now we've got to figure out which one are we looking at. So for theta, I'm not going to be able to find, if I use sine, I don't have an opposite. But what I do have is I've got a hypotenuse here, and I've got an adjacent means next to it. Which one has that? That looks like cosine to me. So in this case, I can find cosine theta will be equal to A over H, which is equal to 5 over 7. So quite simply put, the answer is the cosine of theta, in this case, is that ratio of when the adjacent side is 5 units, whether they're inches or miles, why am I going empirical, or hectares, no, then the hypotenuse in that triangle, given angle theta, will be 7. It's crazy, right? It's crazy. So this one, do I have an opposite? I do. Do I have, what is this guy over here, the adjacent? I don't. So I'm looking for an opposite and a hypotenuse. So that shows me I'm probably looking for sine, aren't I? So for this example, sine theta, that relationship will be a relationship of the opposite side over the hypotenuse side. And the opposite side here is 4. The hypotenuse is 9. Can I reduce that? No. Sine theta is equal to 4 over 9. If I was told to give it in fraction form, if I needed to, I could turn that into, or your calculator would turn it into a decimal form. But it's the same thing. And for this one, I think you can see where we're going. We don't have a hypotenuse, but we do have an opposite side, and we have an adjacent side. So that's going to tell me I'm looking for the tangent, or tan theta. That equals opposite side over adjacent side. So my opposite side is equal to 3. My adjacent side is equal to 5. Therefore, that relationship of tan from the angle theta is just going to be 3 over 5. Let's get to work.